Hello students, I would like to welcome all of you to today's class. In this class, we are going to discuss about electric dipole, properties of electric dipole, that is also called the characteristics, and one very important 5-mark derivation, that is electric intensity at a point on axial line that is due to electric dipole. So this is electric charge and electric field, part 6. Okay, first let us discuss about the meaning of electric dipole. So electric dipole means it is having a pair of equal and opposite point charges. Pair of equal and opposite point charges separated by a small vector distance. That is the meaning of electric dipole. What is the meaning of electric dipole? Pair of equal and opposite charges separated by a small vector distance. So the line joining the two equal and opposite charges, so this line is called dipole axis. This is dipole axis. The line joining the two equal and opposite charges, that is called dipole axis. So let us consider A, that is the location of minus Q, B, that is the location of plus Q. So this is the dipole axis, the line joining the two charges. It is always directed from negative charge to positive charge. Okay. Next, discuss about the properties or the characteristics of electric dipole. The first very important property of electric dipole is a line passing through the dipole axis. A line passing through the dipole axis. That is called the axial line. This is called axial line. This is a line. So that one passes through the dipole axis. What is this? Axial line. And then a point on the axial line, that is called end on position. Point on axial line is end on position. Okay, the line joining the two equal and opposite charges, that is called dipole axis. It is always directed from negative charge to positive charge. Actually, that is the first characteristic. The second one is a line passing through the dipole axis, that is axial line, and the point on the axial line, that is end on position. And this is the center of electric dipole. Let us consider that is O. O is the center of the electric dipole. The distance from point A to point B, that is 2A vector. 2A vector. So this is the distance from minus Q to plus Q. Point A to point B. So what is the distance from O to A? O to A, that is A. O to B, that is A. And a line passing through the center of electric dipole and perpendicular to the dipole axis. A line passing through the center of the dipole and perpendicular to the dipole axis. Okay, so this line is called the equatorial line. This equatorial. This equatorial line. And then the point on the equatorial line, the point P dash. The point on equatorial line. This particular position is called the broadside, broad side, broadside on position, broadside on position. Point on axial line is end on position. Point on equatorial line is broadside on position. And then a plane passing through the center of electric dipole and perpendicular to the dipole axis. So this is equatorial plane. So this is called the equatorial plane. What is the meaning of equatorial plane? That is a plane just passes. A plane that is just passes through the center of electric dipole, like this. For example, this is a plane. This one is just passes through the center of electric dipole. So this is called the equatorial plane. And the point on equatorial plane, that is also called the broadside on position. The strength of electric dipole is measured by the dipole moment. So the mathematical expression for dipole moment is P vector is equal to Q into 2A vector. The strength of electric dipole is measured by electric dipole moment. Electric dipole moment means the product of magnitude of either charge, one of the charge, and the separation between two equal and opposite point charges, or the dipole length. So that is the definition of electric dipole moment. Electric dipole moment is the product of magnitude of one of the charge and dipole length. Product of magnitude of one of the charge and dipole length. So that is called electric dipole moment, and this is vector. Electric dipole moment is a vector physical quantity. Electric dipole moment is a vector physical quantity. The direction of dipole moment, that is same as that of the direction of dipole axis. So what is the direction of dipole moment? That is from negative charge to positive charge. So this is the direction of dipole moment. The direction of dipole moment, that is same as that of the direction of dipole axis, and dipole moment, electric dipole moment, that is a vector. Electric dipole moment is a vector physical quantity, and its SI unit is coulomb meter. So this is the SI unit of electric dipole moment. Charge is measured in terms of coulomb and distance is measured in terms of meter. The coulomb meter, that is the SI unit of electric dipole moment. And its dimensional formula of electric dipole moment is, so the charge dimensional formula is 1 in ampere and 1 in time. Distance dimensional formula is L. APL. 1 in ampere, 1 in time, and 1 in length. 1 in ampere, 1 in time, 1 in length. And this is the dimensional formula of electric dipole moment. And the electric field produced by electric dipole, that is called the dipole field. Electric field produced by electric field produced by dipole is called the dipole field. Okay. So what is the meaning of electric dipole? Electric dipole means a pair of equal and opposite charges separated by a small vector distance. That is the meaning of electric dipole. And what are the properties or characteristics of electric dipole? Number one, the line joining the two equal and opposite charges, that is called the dipole axis. The line joining the two equal and opposite charges. That is called dipole axis. It is always directed from negative charge to positive charge. So this remark is very important. And then a line passing through the dipole axis. So that line is called the axial line. A line passing through the dipole axis, that is called axial line, and point on the axial line, that is end on position. This is end on position. And a line passing through the center of electric dipole and perpendicular to the axial line. This line is called the equatorial line, and point on the equatorial line, that is called broad side on position. Point on equatorial line is broad side on position. And a plane passing through the center of electric dipole and perpendicular to the dipole axis, that is called the equatorial plane. And the strength of electric dipole is measured by electric dipole moment. What is the meaning of electric dipole moment? That is the product of magnitude of either charge, product of magnitude of one of the charge, and the dipole length. Dipole length means separation between equal and opposite point charges. That is the meaning of electric dipole moment. Simply the product of magnitude of one of the charge and dipole length is called the electric dipole moment, and that is a vector physical quantity. So the direction of dipole moment, that is same as that of the direction of dipole axis, that is from negative charge to positive charge. And this is a vector. Electric dipole moment is a vector physical quantity. So the SI unit of dipole moment is coulomb meter. Coulomb meter, that is the SI unit of dipole moment. And dimensional formula. So dimensional formula of charge is 80, 1 in ampere, 1 in time, and dimensional formula of distance, that is L. So finally we will get 1 in ampere, 1 in time, 1 in length. And this is the dimensional formula of electric dipole moment. And electric field produced by electric dipole, so that is called the dipole field. Dipole field. Okay. The next, a very important concept. So write down derivation of expression for electric intensity at a point on axial line. Derivation of expression for electric intensity at a point on axial line due to electric dipole. Derivation of expression for electric intensity at a point on axial line due to electric dipole. And this is first a very important 5-mark derivation in this chapter, that is electric charge and electric field. Okay, so first let us consider here, listen to me carefully. First let us consider here a pair of equal and opposite point charges, minus q, and another one is plus q. This is electric dipole. The line joining the two charges, what is this? Dipole axis. It is directed from negative charge to positive charge. The direction of dipole axis, even the direction of dipole moment. So both are same, that is from negative charge to positive charge. And this is the center, center of electric dipole. So A is the location of minus Q, B is the location of plus Q. Now consider a line that is passing through the dipole axis. What is this? This is called axial line. Now consider an observation point P. P is observation point, the point under observation, point under consideration. Actually, at that point, we have to calculate electric intensity that is produced by this electric dipole. Okay, so now let us consider the distance from point P to the center of electric dipole. This is R. R is the distance from point P to the center of the electric dipole. Okay, what is the distance from B to P? What is the distance from B to P? So OB is A. AB distance is 2A. OA is A. OB is A. So O to P distance is R. So what is the value of B to P? B to P distance is R minus A. R minus A is BP. R minus A is BP. This is R minus A. Okay. And the distance from minus Q charge to minus Q charge to observation point. Minus Q charge to observation point. And this is R plus A. Distance from P to minus Q, that is R plus A. Okay, this diagram is very, very important. Okay, how many electric intensities, how many electric fields are there at the observation point P? So P is near 2-point charges. That means there are two electric fields. There are two electric intensities at point P. Okay, first here let us consider a unit positive test charge plus Q naught. So due to plus Q, what happens? Plus Q naught will experiences repulsive force. That is actually electric intensity at this point P due to plus Q. While calculating one electric field, we just ignore the presence of other point charges. Actually here we're calculating electric intensity at point P due to plus Q. Okay. So due to plus Q naught will experiences the repulsive force. So this is the direction of electric intensity at point P due to plus Q, that is along OP. So this is directed away from the center. EB vector. So EB vector means electric intensity at point. EB vector means electric intensity at point P due to plus Q at B. So due to plus Q at B, plus Q naught will experiences repulsive force. So this is EB vector. EB vector means electric intensity at point P due to plus Q at B. Okay. So that is directed away from the center of the electric dipole. That is directed along OP direction. Okay. One more electric field is also there at point P. Okay. So that is electric intensity at point P due to minus Q at A. Due to minus Q at A plus Q naught at P, plus Q naught will experience attractive force. Okay. Due to minus Q at A plus Q naught at P will experiences attractive force. So that is directed from P to O, P to the center of the electric dipole. Okay, this is the direction of E A vector. So EB vector that is along OP, EA vector that is along PO. Okay, so this diagram is very important. Okay, first let us consider P. P is Q into 2A. So this is electric dipole moment. The product of magnitude of one of the charge and the separation between two equal and opposite charges, that is dipole length. So this is a mathematical expression for dipole moment. So the first step in the derivation, that is electric intensity at T. Electric intensity at T, that is due to electric intensity at point P due to plus Q at B. Electric intensity at point P due to plus Q at B. So that can be calculated by using the mathematical expression. What is that? E is equal to 1 divided by 4 pi epsilon naught Q divided by R square. So this is the expression for electric intensity at a point due to a point charge. Okay. So electric intensity at P due to plus Q at B. So the mathematical expression is E B vector. E B vector, that is equal to 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught. Q divided by distance from observation point to plus Q. Here, what is the distance? That is not R. The distance is R minus A. That is why here R minus A whole square. And this is along which direction? EB vector, that is along OP direction, directed away from the center of the electric dipole. This is along OP. Okay, so the magnitude of EB vector is just EB. Now we should not write the vector sign on EB. Okay, this is only the magnitude of EB vector. Actually, this is the magnitude. What is this? The magnitude of EB vector. What is this? The direction of EB vector. Okay, so this is only the magnitude. EB is 1 divided by 4 pi epsilon naught Q divided by R minus A whole square. Okay, so call this as equation number 1. So, and then electric intensity at again point P. Electric intensity at point P due to minus Q at A. Electric intensity at point P due to minus Q at A. That is E A vector is equal to 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught. Magnitude of this charge is Q divided by distance from A to P, that is R plus A. That is what is R plus A whole square. R plus A whole square. And this is along which direction? A vector along P to O. P to O direction. Directed plus Q naught will experiences attractive force due to minus Q at A. That is directed from P to O. Okay. And the magnitude of EA vector. Magnitude of EA vector. So this is the magnitude of EA vector. This is direction of EA vector. Magnitude of EA vector is 1 divided by 4 pi epsilon naught Q divided by R plus A whole square. Okay. So now call this as equation number 2. Now comparing the two equations, equations 1 and equation 2. So what is your conclusion? So here R minus A whole square is there. Here R plus A whole square is there. The electric field is inversely proportional to square of the distance. So this distance is very small. This is maximum. So that is why. So EB, the magnitude of EB vector, is much stronger as compared to the magnitude of EA vector. The magnitude of EB vector is much stronger than the magnitude of EA vector. Okay. So vectors, two vectors acting at the same point but in opposite direction. Two vectors acting at same point but in opposite direction. The magnitude of EB is much stronger as compared to the magnitude of EA. Two vectors acting at the same point but in opposite direction. What is the angle in between them? 180 degree. So the magnitude of resultant that can be calculated by using the formula R is equal to root P square plus Q square plus 2PQ cos theta. So here the value of theta is 180. So R is equal to root P square plus Q square plus 2PQ cos 180. Cos 180 is minus 1. And then R is equal to root P square plus Q square minus 2PQ, that is P minus Q whole square. Root P minus Q whole square is P minus Q. So the resultant, the magnitude of resultant is P minus Q. So here P is EB, Q is EA, because EB is much stronger than EA. Okay. So comparing equations 1 and 2, what is your conclusion? The magnitude of EB vector is more than the magnitude of EA vector. Magnitude of EB vector is more than the magnitude of EA vector. Okay. So the resultant, the magnitude of resultant of EB vector and EA vector is, let us consider, that is E axial. This is electric intensity at point P, point on axial line, that is due to n-type electric dipole. Okay, that is equal to EB minus EA. EB minus EA. So electric intensity at a point on axial line is equal to. So this is the value of EB. Okay, EB is 1 divided by 4 pi epsilon naught Q divided by R minus A whole square. So A, this is EA. EA is 1 divided by 4 pi epsilon naught into Q divided by R plus A whole square. So from these two equations, Q divided by 4 pi epsilon naught, Q divided by 4 pi epsilon naught, that is just taken as common from equation 1 and equation 2. From these two equations, Q divided by 4 pi epsilon naught, this is common, right? Let's take it as outside. Then we will get here Q divided by 4 pi epsilon naught of remaining is, so here the remaining is 1 divided by R minus A whole square. 1 divided by Q divided by 4 pi epsilon naught is common. 1 divided by, remaining is 1 divided by R minus A whole square. So minus, here the remaining, again here Q divided by 4 pi epsilon naught is common. The remaining is 1 divided by R plus A. 1 divided by R plus A whole square. 1 divided by R plus A whole square. Okay. So now the electric intensity at the point on the axial line is equal to Q divided by 4 pi epsilon naught. So what is the LCM here? What is the LCM? R minus a whole square into R plus a whole square. R minus a whole square into R plus a whole square. So what is the value here? R minus a whole square, R minus a whole square cancels. The remaining is R plus a whole square minus here what is the value? It is R minus a whole square. Okay. So and then electric intensity at a point of the axial line that is equal to Q divided by 4 pi epsilon naught R. So R minus a whole square into R plus a whole square. Actually, that can be written in the form of R minus a into R plus a into R minus a into R plus a, right? So R minus a into R plus a, that is R square minus R square minus a square. Again, R minus a into R plus a is R square minus a square, right? R square minus a square into R square minus a square, that is R square minus a square whole square, right? So R minus R minus a square into R plus a square. That can be written in the form of R minus a into R plus a. Again, R minus a into R plus a. R minus a into R plus a, R square minus a square. Again, R minus a into R plus a, that is R square minus a square. R square minus a square into R square minus a square. That is R square minus a square whole square. So R plus a whole square. What is the formula of R plus a whole square? It is very simple. R square plus a square plus 2RA. R square plus a square plus 2RA. So minus of here R minus a whole square. That is R square plus a square minus 2RA. R square plus a square minus 2RA. So and finally electric intensity at a point of axial line is equal to Q divided by 4 pi epsilon naught of R square plus a square plus 2RA minus is taken as inside the bracket. What happens? Minus R square minus a square minus into minus plus 2RA whole divided by R square minus a square whole square, right? So now R square, a square get cancelled. The remaining is 2 into 2RA. Q divided by 4 pi epsilon naught. Q divided by 4 pi epsilon naught. 2 into 2RA. 2 into 2 times 2RA divided by R square minus a square whole square. And finally 1 divided by 4 pi epsilon naught. 1 divided by 4 pi epsilon naught. Q2A. Q2A. What is that? P. Q2A, that is P, electric dipole moment. So 1 divided by 4 pi epsilon naught. 2 PR. 2 PR divided by R square minus a square whole square. So that is the expression for electric intensity at a point on the axial line. That is 1 divided by 4 pi epsilon naught 2 PR divided by R square minus a square whole square. That is electric intensity at a point on axial line. Okay, right? So in vector form, in vector form, that can be written in the form of, this is in vector form of electric intensity at a point on axial line is E axial vector, that is equal to 1 divided by 4 pi epsilon naught 2 p r divided by r square minus a square whole square, okay, into p cap. So this is the magnitude of electric intensity at a point on the axial line, and this is the direction. P cap is a unit vector, indicates the direction of electric intensity, resultant electric intensity at a point on the axial line. What is the direction of resultant electric intensity? Direction of resultant electric intensity, that is along the direction of greater magnitude vector. What is that? That is EB. EB vector having greater magnitude. So the resultant is also along OP, that is along the dipole axis, that is from negative charge to positive charge. That is along the direction of dipole axis, along the direction of dipole moment. That is the direction of electric intensity at a point on axial line. P cap is the unit vector, indicates the direction. The direction of E axial is along OP, along OP. Okay. For short electric dipole, for a short, for a short electric dipole, for a short electric dipole, for short electric dipole, R is much greater compared to A. Suppose the point P lies far away from the center of the electric dipole, so R is much greater compared to A. So in this case, A square is very small, that is negligible. A square is very small, that is negligible. Okay. So finally, for short electric dipole, electric intensity at a point in the axial line is E axial, that is equal to 1 divided by 4 pi epsilon naught 2 p r divided by. So A square is negligible, so r square whole square becomes r power 4, right? And then electric intensity at a point in the axial and is equal to 1 divided by 4 pi epsilon naught. So 1 get cancels, the remaining is 2p divided by what? R2. This is the expression for electric intensity, a point on axial line due to a short electric dipole. Okay, thank you.